Alright, so we are resolving example 2, but this time around we are trying to see how we can use a calculator to make our work faster, right? So then we saw that we are trying to find I4, trying to find this I4 here, and then we saw secure that I1, I2, and I3 are entering a node, and I4 is the one exiting the node. So we are trying to find that, right? And then the other thing we saw is that when we're adding phasors, the phasors with the same frequency are the ones that we're able to add easily, right? So let's see. These are the ones that we add, right? The ones with the same frequency. So clearly here we could see that this side, the ones in blue have the same frequency, right? And then the ones in green have the same frequency, right? So we add them. And then the other thing we saw is that when we are doing this, we are trying to find the I4, for instance. What we saw was that one the things that we need were that we find some kind of like S component. So let's see, we find an S component, and then we find a Y component for each frequency, right? For each type of frequency. So like if you are solving this part here, we find S component, Y component, right? And what do? We find the VM, or the peak value. So sorry, this peak value in this sense here, because it's current, it's actually peak value IM, right? So peak value, right? And then we find the theta, which is basically the phase shift, right? Or the phase angle, or phase angle, phase angle. Alright, so if you follow the discussion that we did just before this, that's example 2. These are the main things that we're finding, right? But then it can get a bit clumsy. So we are using a calculator to see how we can make it faster. And then we do this for each and every, so we do this for each frequency set, right? So then that's what we're going to do here. Try and make it as fast. We're trying to make it as fast as possible so we can get to the answer that we need. We're just organizing things. Each frequency set. Okay. So now we know what we need. We need x, y, the peak value, and then we need theta, right? And in fact, we use this once to find this and then this, right? So now we're going to go over this. We find the s component. Generally, we use what? Cos. So let's go over this. We use cos, right? When we find the y component, we use what? Sine. Right? We're just revising something to make our work easier. And we are finding this im, or the p value. We basically use root, right? So we get root here, and then we get s, and we get s component. It could be plus or minus, right? So let's see. Let's do this. Just plus or minus, and then we square it, right? And then we add the y component, plus or minus, right? And then we square it, right? And that gives us just the p value. So now we are just doing this so that when we start, we know we are going here, here, here. Makes our work easier. And when you have this in mind, wherever it is that you meet a problem of this sort, you'll be able to ease it with colors, right? So let's see. Alright, and then when we are finding the phase angle, basically use tan, right? And when we are finding the phase angle, we use tan. A minute. Just summarizing these so that you're able to follow easily. Okay. But then if you're not familiar with what we are doing now, you can check the example 2 that we did earlier, just to give you an understanding of what we are doing here. But here it's like we've done the work already, but then we are trying to see how we can make it faster. Okay, so when we're finding the phase angle, phase shift, or the theta, it could be any symbol. So at times you even see it as this, you even see it as this. It could be anything, but the most important thing that is is the phase shift, right? So that's tan inverse, right? And then we opposite, right, over adjacent. This is usually y, right? And here too we use the plus or minus, right? We use the sign that's in front of the x or y component, right, over the s component, plus or minus, right? You use that. So when it comes to the square root inside, you use it, the plus or minus, the sign in front of it. When it comes to the face shape, you use it, the sign in front of it, the plus or minus, right? Okay, so now that we've summarized everything, we're going to go through it very fast. But then we use a table to make our work easier, and that's how we do it. So let's see. So for a particular frequency, so let's see. So let's say for this type of W, right? For a particular angular frequency. Okay. Okay. Let's bring this down a bit. Okay. So for a particular frequency, what do we have? We first of all get S component, right? And then we get Y component. Let's say X part. So let's just write this. X, Y, and then we have our peak. Because here we are doing current, you use I, so IM, and then we get the theta, right? The units of this are just numbers. This is current. If you are writing a table, this should be amperes, and this should be in degrees, right? Okay, so now we are going to it. We are going to do it straightforward. Now we've seen what we're supposed to do. We are moving straight to it. Okay, so this will be the view part. When you do it this way, because you understand what you are doing, you can add things up straightforward to be pretty much more clear. So you have everything just on one table, and you have the 3W. Okay. Alright. So now let's see what we have for these ones. I think we should put them close by so we know what's happening. Let's see. So then again, this is something that we've solved already, but then we're trying to see how we can use just a structure or a system, right, with the aid of a calculator to make our work faster and then clearer, right, because we know the basis of what we are doing at the moment. Just that we are trying to find how we can go about it and then still get the what do you call it, the solution that we are looking for, right, but at the same time trying to reduce the time that we take to solve something of this sort. Right. So then again, this is AC, right, and we are doing Phasors. We are adding subtracting Phasors, but this is the type that the Phasors are not, they are not two, they are more than one, right, and they are not 90 degrees to each other. So this is the type that we are trying to do. It's different from the example one we solved. Just a top up. Okay, so now we have this. Let's see. And then we've explained that from example 2, there's certain things that we need when we are solving something of this sort, just to make our work flow. We've identified that we have the x component, y component, right? We have the p value, and then we have theta, right? And then with the aid of a table, we've put that there. So now what we're trying to do is we know the formulas we are supposed to use, right? So then we will go straight forward and do this. Alright, so because we are using a calculator, let's split the screen so you're able to follow. We already know the formulas that we are supposed to use, so that makes our work easier and makes it flow well. Alright, so now we have our table, we have what we need, so now we move on. So now we are dealing with this side, and minute. Okay, so now we are done with this side, right? The W, just the W, the frequency of W, right? The angular frequency of W. Okay, so with this, so let's see. Okay, so meaning that we are not dealing with, we are dealing with just a particular side, right? Which is this side here, this one. Okay, so now if you are trying to find the S component for that particular one, for this, so we start with this one right here, right? So that one is just straightforward, right? So you can see that there's no phase shift here, so it's just 5, right? 5 plus, what's the next one? This is 8, and there's a phase shift, so we do 8, right? And we do cos, and we do what? Pi on, pi is basically 180, and that's 180 on what? 3. And what we have, we are done with this, we are done with this. We come to this, that's 15, right? And cos, and then what we had there is pi on 4, which is 180 on 4 on 4, and this is what it gives us. That's 9. Let's do 4dp. That's 19. Excuse me, I think I'll have to write this a bit small. 19. I'll bring the decimals down. 6066. Now we must consider when we are doing it this way, because we know what we are doing, that you should be able to imagine the coordinate system or part of the coordinate system, the Cartesian coordinate system where you are, right? So for this particular one, where we are still dealing with this one, right? So we know that 5, because there's no phase angle here, right? There's 0 here, mean that 5 lies this way. So first of all, let's draw the coordinate system. So we have this Cartesian, right? So we know 5 lies here, right? And then the 8, because it's a positive here, a lead is somewhere here, and then the 15, the lag is somewhere here. So meaning we are here, right? Okay, so that's one thing we should be able to do to visualize what we are doing, right? It's safe to write it somewhere. Okay, so now we are done with the S component. Move on to the Y component, right? We still keep this phases here, right? Okay, so because it's x, looking at this one, we see that the x is still here, so it's 0, right? So the 5 is, if you find the Y component of just the W side, the W frequency, right? Angular frequency is just 5, right? So that one tends to 0, right? And then the 8, you see this is the number, right? So this is the 5. I'm just using their peaks to identify. This is the 8, right? And there's the 15, right? So the 5 is 0, the Y component of it is 0. The 8, right? The Y component, you see this is a positive Y, this is negative Y, this is positive X, and this is a negative X. Alright, so then looking at it very well, if you're trying to get the Y component of 8, it should be positive, so positive, and we'll find the Y component to sine, right? The sine. And then the 15, let's look at it very well. The 15 is here, right? If I find the Y component, it comes to the negative Y axis. So first of all, it is minus, then the next thing is it is sine, right? Sine, yeah. So you know that this is all give us for the Y component, right? So we have minus, very important, should be there, minus 3 points. We are doing 4dp here, 6, 7, 8. But then the decimal place should be done according to what's been given. At times it's stated in the instructions clearly. If it's not, it's safe to go by 4dp. 6, 7, 8, 4, right? Alright, so now we trying to find the peak, right? The peak is straightforward. The S component squared plus Y component squared, or whichever way you want it, whether Y first or something. So 19.6066, and then we have minus, very important, minus 3.6784, right? and that gives us 9. This it gives us 19.9487 approximately. Now we're trying to find our theta, right? So theta, we've seen what we do with it already. So tan inverse, right? Opposite. The y will be the opposite, so that's minus 3.6784. The x we have 19. Then again, it's very important to bring the minus for the 3, right? So we get the whether it's leading or lagging. 19.6066. So this gives us the phase angle showing that it's lagging, so that's minus 10.6258, right? It has given us the whether negative or positive, so it is telling us that it's what lagging because it's what negative. The phase shift is negative. Okay, 6258. 8. Alright, so now we are done with this side. What we do now is that we're done with this as well. What we do now is that we are done with this side. Alright, just the same procedure, right? So let's see. We're trying to find the S component. Looking at this very well, this side, right? Looking at this side, right? There's no phase angle here, right? So it's just that one. There's no phase angle. So if you are finding the S components, is we have, so first of all, let's try and see if we can draw the phasors, right? So there's a coordinate system, right? So we said we are done with this one. There's a coordinate system. Where will the 5 be? The 5 will be here, right? It's in line because no phase shift. The 8, so there's the 5, and then the 8 is minus, so lagging. There's the 8. I'm just using their peak values to identify them, right? Okay, so now we see what's happening. So we're finding the S component. We have just 5, right? The other S component, it will match to this side, so it's still positive, right? So plus, and then we have what? 8 cos, and the phase angle is 180 on 3, which is about 60. 180 on 3. But it's safe not to be thinking through these things when you know how to use a calculator to solve it for you. It makes it faster, and it gives you the more thinking space to do something more important, to follow something, pay attention to the things that are more important, right? And then we have so we have 9 here, right? And we're trying to find the y component. Okay, for the 5 again, we've changed the y component because in line with the x-axis it's still 0. So 0, it goes out. 0, so just put 0 there, so it's clear. Right, so for the what do you call it, the 8 and this one right here, we are trying to find the y component. It comes here, so it's negative, right? So negative, we change this from first to negative. Right, the next thing is that because it's y component, we use sign, right? Okay, so this gives us minus, very important, 6 minus 6.9282, right? Let's try this one. Okay, right, so now trying to find a peak, so we just do square root. It's safer to put what do you call it, the formula in before you put in the values, right? It's very I see it's safer, but whichever one works for you is fine. So minus 6.9282, and that gives us what? That gives us 11.3578, right? So now we try and find the phase angle, the phase shift. That's tan inverse, right? The y component, that's minus 6, minus, very important, minus 6.9282, and then the s component is 9, and that gives us minus again. The actual question, there's something slightly that we changed, so we are going to correct that. Here is a plus, so let's see. Here is a plus, right? Is a plus. Minutes. Here is a plus. Okay, so if that side is a plus, what means is that when we are drawing the Phasor for that, this side is no longer here because it's a plus, it's leading, right? So it will be here. So that's where the 8 is, right? So we are just going to correct something. It's just a bit slightly different. The magnitude is the same, just that the direction is always opposite, right? So if you are trying to find the y component again, right, the only thing that will be affected is the y component, right? It becomes positive. So we have just, this is 0, right? The y component is 0. So for the 5 is 0. For the 8, you have 8 sine a minute because it's positive. So let's put the 8 sine, yes, plus, as we said. Yes, plus. It's leading, not lagging. Okay, so we have 180 on 3, and that gives us this, right? So it's positive. The only thing that will change is the sign, just the sign. Okay, direction has changed. That's all. Still the same thing. Okay, what we mean is that our value, our directions will change as well. So then let's see if you are trying to find the IM. So this one we are also verifying your work to see if you're on the right path. So let's see. The square root, the squared, the squared. So we have 9, and we have 6. Because it's squared, that one will still be the same, right? 6.9282, right? It's the same thing. What will be affected will be the phase angle, right? So we have tan inverse. We have the y component, which is no minus now, 6.9282, and then the x component is 9, right? So instead of it being negative as we saw earlier, to be positive. So positive, very important. 37.4 dp, that's 5891, right? So that's what we have. So if you are trying to simplify all this, all it means, what we are doing is that we end up getting our I4 this way. So let's see. I'm trying to write our I4. So I4 is equal to, so we know the general formula, right? So we have the peak because it's current. So let's see. So we have the peak. So I peak, and we have the sine, right? Because they are sine waves, and we have this, it could be any number, positive integer, and then we have the angular frequency, we have time, and we have the phase shift, plus or minus, right? Okay. So now here's the problem where we have it in different, we have different frequencies. So we add the different frequencies, right? So let's deal with the first one. So now we are dealing with this particular one. Let's see. The one in brown. Okay. And then with the W part, right? So the peak is what? 19.9487. So that's 19.9487, right? And that one for that one is still sine, right? The sine wave. For that one, the frequency is just WT, so just WT. And then looking at this, the phase shift is lagging. Alright, so that's a minus. It's there straightforward. Minus 10.6. Let's say 0.62 degrees, right? Plus, right? So we have a plus here. Alright, and now we add the other part, which is the 3W frequency, right? So for that, the peak is 11.3578 sine a minute, yeah, sine. For that one, the frequency is 3W, right? So 3W, the angular frequency, right? And then the phase angle is plus leading, so 10 plus 37 point what 5891. So let's see, about 59 degrees. So this whole I4 that we're looking for, the whole I4 that we're looking for When we add everything up, that's what we get. When we add everything up, that's what we get. Clearly, it's just the same as the example that we're solving when we were just using the diagrams and everything. But here we just use the calculator and a table, right, just to make sure our work flows, and then we get to see everything clearly because we understand how to go about everything already. So that's it. All right.